dilations today. How many of you guys have ever been to the eye doctor?
Me! No,
What do they do at the eye doctor? They check your...
They shine a very bright light in my eyes.
What do they do before they shine the bright light in your eyes?
They make you look at pictures.
They make you look at the letters.
No, they made me look at pictures.
Even before that. But before they shine the light in your eye, they give you the drop, right? They tell you to wait outside because what's happening? Because they're dilating your eyes. Alright. They're dilating your pupils. Now, alright. And so we're talking about dilation today. And when your eyes get dilated at the eye doctor, it makes your pupils bigger, but they stay the same shape, right? They're just a bigger circle.
My friend is
It's like sweet potato
Right. All right. So in math, dilations both get larger and smaller. All right. So we can have a dilation that gets larger, and we have a dilation that gets smaller in math. So that's what we're talking about today. All right, they're always performed with respect to a fixed point called the center of dilation. I am. Blank is not big enough, is it?
Yes, it is. Alright, big. The letter.
All right. The scale factor of dilation is the ratio of length on the image to its corresponding length on the pre-image. Which one of those is the first one?
The chicken.
The pre-image. The pre-image is the original. And we use the letter K, lowercase k, represents scale factor. The value of K determines whether it's an enlargement or a reduction. So if K is greater than 1, that is called an enlargement. If K is less than 1, then that is a reduction. All right? Everybody with me so far?
Yes.
All right? So if it's an enlargement, the new shape will be bigger. The K is going to be greater than 1. If it's a reduction, the new shape will be smaller. It's fine right there.
No, it's not. I need to know.
If it's
my mom.
What?
all right.
Someone said I look like my mom.
So we're going to look at these examples. We're going from A to B. That means that A is the original and B is the new shape.
Oh, sorry.
Tell me is it an enlargement or reduction, and then figure out the scale factor. All right, so for this first one, is this enlargement or reduction?
Reduction.
It's a reduction. All right, our scale factor is always the new distance over the old, image over pre-image, image over original. So when it's laid out on a grid like this, we can just count squares. So this distance on the original, this horizontal piece is the easiest one to do. Is 1, 2, 3, 4, 5, 6 units long. So that's 6. And then this piece right here looks like it starts at the half. So that's a half, that's 1.5, that's 2.5, and another half makes 3. So if it's the new over the old, we write 3 over 6. And so that means our K is going to be 1/2. And that's what we'd expect because we said it's a reduction, so that means it gets smaller. Right? So that's K is 1/2, and it's a reduction. How about the second one? Going from A to B.
Enlargement.
This one's an enlargement. Okay, and again, counting squares, this distance on A, the original, is 1, 2, 3. And this same vertical distance on B is 1, 2, 3, 4. So our K is what? 4 over 3. It has to be greater than 1 because it's an enlargement. So K is 4/3. Pretty easy, right? It always does. Alright, this part's not that hard. So now we want to find out if this is a similarity transformation. Similar in math means same shape, different size.
Wait, what?
Same shape, different size. That's what similarity. And everything has to obey the same scale factor. For instance, if we consider smart water bottles before they're dented, right? They all look like this, yeah? But what about the really big ones?
They're like the bigger version.
They're this, but they're not. But it's not mathematically similar because what's the same?
Coach Stone, you might want to make sure what you're driving.
The water?
Make sure you have that in her mouth.
The water is still the same water.
The water's still, but what about the bottle itself is the
It
same?
just got larger.
Small ball. How's it
The lid, the cap fits on them both, right?
They do?
Yeah. So the cap fits on it no matter what. Thank you.
See, from here it looks bigger, but from over there it looks small.
No, it looks the same size.
So those bottles would not be mathematically similar because there's something about it that's the exact same size. Everything has to obey the same scale factor. Everything. So we can look at these two shapes and determine if they're similar if every segment obeys the same scale factor. So I'm going to first compare JK to PQ because those are the corresponding segments. I'm going to look at the horizontal and vertical distance of each. This is kind of just like when we did fractional distance. We would look at the horizontal component and the vertical component and compare the two. And then just see what the ratio is, and that'll be my scale factor. Now, if I'm going from JKLM to PQRS, is that going to be an enlargement or a reduction?
Wait, JK to what?
If I'm going from JKLM to PQRS, it's a reduction. So my scale factor should be something less than 1. So if I look at JK, the horizontal distance it covers is 1, 2, 3, 4, 5, 6 units. And the vertical distance is 2 units. Alright, so it's 6 units over, 2 units up. If I look at PQ, this one starts at the half, and it goes half, 1.5, 2.5, and about 3, and then up 1. So it goes horizontally 3 and vertically 1. So what's the ratio of these distances to this distance?
1/2.
1/2.
Oh, 1/2.
It's definitely 1/2. Alright? So now I'm going to do the same thing for KL and for QR. KL goes 1 and 3. QR goes 1/2 and 1.5. So what's the ratio between those two?
Wait,
1/2 to 1 and 1.5 to 3.
that's 1/2.
1/2 also. And then I'm going to do LM and RS. LM goes down 2 over 6, so that's 6 and 2. And RS goes down 1 over 3. So again, that's 3 and 1. What's that, K? 1/2. And then finally back to the beginning, MJ is 1 and 3, and SP is 1/2 and 3/2. So that K is also 1/2. So if all of them obey the same scale factor, what can we conclude? It's not congruent. They are
Similar.
similar. These are similar. They are similar.
I just want to this.
Thank you. Any questions over page 1?
Yes, will you
Don't
please
change
leave
it,
it
don't
there
change
for
it.
a second because you went really fast tonight.
It's already been up there for several seconds. See?
Ow.
All right, we got it? Okay, how about now?
What?
Stop.
Okay, how about now?
Wait.
Give us like 5 minutes.
No, that's too long.
What?
Okay, how about now?
Alright, 10 minutes. That's better.
You write really fast.
Coach Stone, you have to realize there's a bunch of high schoolers.
I'm already done.
Any pictures?
All right.
I care about how my nose looks, so I don't want my fingers to be sloppy. Okay.
Unlike when you're a quote of the week.
Did you seriously check that out?
Well, it's not very high up, so.
All right, here we go. On to the back.
Ew.
All right, we are making a similar shape to this here postcard. This is a rectangular postcard. Has these dimensions. And we're going to make a postcard that is similar but with a length of 7.5. So that means the length on the new version is 7.5. What's the scale factor? How would I find the scale factor?
No.
New over old, so what are the numbers here?
We're drawing?
Wait, what?
7.5 is the new, and what's the old? 6. So 7.5 over 6. If I multiply both by 2, I get 15 over 12. And then 5 goes into 15, 3 goes into 15 5 times, 3 goes into 12 4 times. So K is 5 over 4.
I can't write tape. It's really hard for me.
It doesn't look like a K at all.
Look at that.
That's an N.
That's a K.
It's not
I know the dime.
7.5 and 6.
That's hard.
2.
Whenever I'm writing fast.
All right. Lastly, we're going to talk about scale models. And this is
Keep that part off the like slide it down.
so this is actually how we used to figure out distances on maps. Is if you would have a paper copy of the map, an atlas or whatever, you would take a ruler out and figure out the distance on the map from point to point. And then, yeah, if you didn't have the ruler, you're screwed.
No, you have
Then you would use like a pencil, and you would mark it on a pencil, and you would go try to see how many of those pencils were on the scale, because the scale was always usually drawn.
You didn't have a pencil.
Then
I
you were
would get
screwed.
lost having that.
All right.
Imagine being a boomer.
What if you didn't? What if you had a pen instead of
Okay, boomer.
Hey,
Be a
Yeah.
boomer.
We're boomers.
There's no boomers in here.
You're a boomer.
No, I'm not.
You millennial.
No.
What
I'm
are
in between Generation X.
Gen X.
Yeah.
Well, I'm Gen Z, so. Really?
We don't know what we're going to call you people yet. All right. So if the scale is 40 miles is 0.4 inches, then we get to set up a proportion or ratio. So I know that 40 miles is 0.4 inches, and I'm trying to figure out how many miles is it for 1.5 inches.
I honestly don't know.
Why'd you wait? Why'd you just laugh?
So, Landon, yeah, pay attention. So if I've set it up like this, how do I solve?
Oh, cross ones.
I cross multiply. Every algebra student's favorite thing to do. 40 times 1.5 is 60. To equals 0.4x. I divide by 0.4. 60 divided by 0.4 is, somebody tell me please, somebody.
What are we gonna do?
60 divided by 0.4.
40.
It's going to be something bigger because I'm dividing by a number less than 1.
40.
It's 73.
90.
74.
150.
75.
90.
It's 12, 20, 4.
Wait, what?
60 divided by 0.4.
Wrong, never mind.
150.
Yes.
Cheater.
I already said 150.
No, you didn't.
You were right when you said that.
So what? Why didn't you say
Yeah.
that?
Because
I didn't hear you.
didn't be
I
right.
said I literally said 150. You go. What'd you say?
She said 24. I thought she was doing it right. All right.
Can you just say 4 and you go to 20 and
Last problem.
It's just
5 times and 5
All right. If the problem is talking about a rectangle, what's the very first thing you should do?
Draw rectangle.
Draw a daggum rectangle.
Oh my god.
A circle.
Coach Duhon, what would you do if the administrator walked in here and heard you using that profanity?
What? Daggum?
Yeah. Sound like so many
All right.
now.
Now,
Very offended by it.
what do we know about this rectangle?
It's nice.
It has 4 sides.
Okay. It is what?
3
3 centimeters long and 1 centimeter wide. Now the scale is 2 centimeters is 5 kilometers. So I'm trying to figure out the kilometers for each of these. So again, I set up the ratio.
Ratio.
So it's 5 kilometers is 2 centimeters. And to find the length, it's the length divided by 3 centimeters.
So you do cross multiply.
I cross multiply again. 15 equals 2L. So L equals 15 over 2, which is 7.5.
Do we have to draw an L like that? Or no?
I would recommend it because if you don't, it makes it look like a 1.
Not to do uppercase L.
If you did an uppercase, it would. And then I've got my width over 1 because it's 1 centimeter, and that's easy. W equals 5 over 2, which is 2.5.
Yo.
So my area is 7.5 times 2.5, which is...
5.
What is this one, Anthony?
Wait, what is
You have all the answers. What's this one?
2.5. Which is
I smell
Wait, what is it?
7.5, 2.5.
You smell what?
7.5 times
3.
3.1.
3.1.
18.75.
18.75.
It's probably
Yeah,
thinking
that's
about your day
hard.
last night.
I wouldn't never guess that.
You don't have to guess, you just have to know.
Or look, you can say, okay, hey, it's 2 times 7.5, I know that's 15, and then 0.5 times 7.5 is half of 7.5, which is 3.75. 15 plus 3.75 is 18.75.
True, true.
I agree with you.
That is the mental math that you guys were never taught when you were
Well,
Yeah,
I
I
never
agree.
wanted to. It is what it is. It's not like.
I can't do that.
All right, hey, I'm going to work out the first problem on the homework
Okay, but don't move this.
We have all
once we're ready, and then you're going to have all the rest of the class to do the homework,
Yay!
You know,
which will be about 30 minutes after I do the first problem.
it's hot.
Are we ready?
No,
Okay, how about now?
still not.
Okay, how about now?
Nope,
Yes, we're ready.
we are not ready.
No, you're not ready.
Blakely is not ready and Blakely.
Okay, tell you what, I'll pause it and then we'll record.